Hello, everybody, and welcome back to another forecast. So I'm back from a brief hiatus, a little vacation of mine. Not much of a vacation. High schooler, gotta do my schoolwork first. But hopefully I'm back for till next year when I go to college. So what we've been seeing going on for the past few days actually is a moderate risk down here in the Gulf Coast states, right here, I believe. 15% hash tornado risk. We didn't actually see that really come to fruition too much either. I'll look up storm reports real quick. Here's our storm reports for that day, right here. Got a few little instances of tornado reports. Not really what you'd expect to see from a moderate risk. Honestly, not a bunch of high wind risks either. Not much damage really overall. And at the moment, I believe we are actually under average for tornadoes, but that does look to be changing. In our events that we've been seeing going on, we've mostly been seeing a lot of large hail in the Texas, Oklahoma region, kind of our standard Dixie, not sorry, Tornado Alley region where you'd expect to see large hail. High Cape Valleys gets really hot here. Seeing a lot of large hail there and kind of gorilla hail we've been seeing. But this break from tornadoes is definitely looking to go away pretty soon. For today, tomorrow, and the day after that, today, this is Saturday, this is Sunday, we're seeing 3 days of marginal risks. Nothing really significant in that sense. However, 2 days ago, the SPC issued a 15% region. Actually, I believe this might have been day 7, there's a 15% region. And there's a day 6, 30% region for severe weather. So very well predicted at this point. We have a day 4 and day 5 at the moment. The other days are a little unpredictable. They're too far out, but the models have been agreeing for a long time. We're going to see severe weather right here and very significant outbreak in this region. Mainly, that's what I'm going to be focused on in this prediction. Looking at the GEFS model mainly for a second at least, so we can. I'm gonna get into that forecast part now. See this ensemble GFS model here, and on Monday, right about where you'd expect storm hour to be, have a pretty negatively tilted trough, flows, strong flow, especially starting to exit this trough now. You can also see the fluence, right? So you can see these contour lines are going apart. That means there's likely to be air filling from underneath that'll help really boost those storms. There's a lot of forcing as well. Something you'd want to see. Our ensemble GFS as well shows quite a bit of cape being kind of spewed all over. Although there's quite a little bit of a gap right here in the Oklahoma region, so I'll be looking at that later as well. I do think it's kind of interesting considering the fact that SPC has issued that's our main risk of severe weather. So how that looks, we'll be seeing in the future. And then the next day, we're going to see this trough continue to move on to the east. The 15% basically has this whole region kind of in it. See it right here. Shape just about the same for the day 5. Illinois involved as well. So if anything's interesting going on, I might be able to actually see some of that myself. Yeah, this trough will then eject to the east as well, kind of shearing out very quickly. Nothing too severe looking to come after that. Maybe another brief return. Not much to see here. And the GEFS obviously starts to even out after that point. The GFS model itself, you might also be able to see what will happen to that trough. Very quickly sheared out. You might have a second round of severe weather somewhere in this corridor. Another trough from the north kind of swinging its way down. So maybe some severe weather here. I'm not 100% sure on what's going to come out of that, but good open warm sector for all of this. We've been seeing for the past few days. Right now we have a huge low pressure system that we saw from the moderate risks down here in Dixie Alley. That's been moving on to the north as so. What we're going to be seeing now is a strong ridging putting itself in place. You can see the surface here. Here's our high pressure. You can see how the rotation is clockwise. That's pushing flow from the Gulf. We also have kind of a little bit of flow from the west coming in. Not too much, but our main way we're getting our better temperatures and better dew points is from this high pressure here. Strong flow up here. You can see even in Montana, it's forecast to be 52 degrees tonight. So very impressive for that regard, and very warm across the entire United States. We're seeing a lot of warm temperatures. Dew points will continue to set back in. You can see here Sunday, and then Monday is when we just continue to see this plume it just keeps going on. At the same time, we're seeing that 500 millibar trough moving its way through. Again, very large amplitude, and defluence is definitely available. And we're gonna see probably good Cape values from this as well, just because how warm it is, and again, moisture's there, temperature's there. And Cape does seem to be there. Shear is definitely there. I can take a few soundings from our risk area. At 0Z about storm hour, you can see, if you look at the surface map, dew point temperature is a pretty sharp dry line. To be fair, I'm going to move to the NAM model now because looking at the GFS is not the best idea for medium range forecasts. The name model shows something very similar, very strong moisture moving into the region. It also shows a very extremely well defined dry line here with 17 dew point, 17 dew point on this side and 64 right across that border. Cape values, looking at mean layer cape. Main thing we're seeing here is just a lot of cape close to that dry line, nothing really shed off anywhere else. So in the south, we might see more of a linear mode just because of how these storm motion vectors are looking. You can see they're a little bit more parallel aligned in some senses, although some of them do go off the line pretty well. However, you have to keep in mind supercells, when they originate, they actually have a splitting part in their cycle, right? So if you have a supercell moving like this, if it decides to split, you get a left mover and you get a right mover. And that right mover will end up being very parallel or completely perpendicular to the line, excuse me. Completely perpendicular to that dry line, and it'll be completely discrete. If any of those supercells can form, they'll free reign over this whole region here. Take a few soundings now. Take one from Texas. Take one from kind of this Oklahoma plume right here. I also think the region up here is interesting because you have a few of those kind of more cold core setup supercells where they move completely north. But there's a lot of more cape in the north up here in the higher elevations as well. Take one from Kansas, and I'll take one from Nebraska on the higher elevations. We're seeing from our Texas sounding here, kind of supercellular sounding. Here in the lower levels, that's what you want to see. And then a little bit of backing, which is also something you want to see for supercells, and then jetting off the precipitation. Not super strong in this case, however. So you could see maybe higher precipitation supercells. We also have pretty good cape in our tail growth zone, so that could mean that some of these supercells could be pretty strong with cape. Maybe a little bit of an inverted V as well. You can also see there's a little bit of a semblance of an EML. Drier air in this region, and it's kind of a little bit of a cap being put in place here. So maybe storms might form a little bit later on in that southern mode. The NAM does get that far, so if I move to a more recent model, take one from Texas again here, hopefully give us a better result. But yeah, definitely that possible cap right there. Oklahoma sounding somewhat similar, although the EML is not really in place, and a lot more 3 cape, so completely uncapped environment here. Shear in the lower levels, jetting off of the precipitation, definitely a very good hodograph. Very good CQT as well. Strong cape, 2400 joules per kilogram. Also 200 joules per kilogram and 3 cape. So definitely a very good sounding here you want to see. So I understand why they have the 30% right here in Oklahoma. Very good for supercells. Up in Kansas, this increases even more. You can look at this shear. This is absolutely absurd. Kind of horrifying sounding, to be honest with you. You can see the precipitation being jetted off way up here, but very good supercell hodograph. The STP is at 6.5, which is insane. So I think the Kansas area is definitely the main area of interest for tornadoes, in my opinion. Based on what I've been seeing from the NAM and the GFS especially, I can try taking one from the GFS. I think this more northern route might even be better for tornadoes. The NAM is definitely showing more apocalyptic thing in that regard. Then other NAM model didn't show very good photograph here as well. This is our Kansas one. This is our more Nebraska-based one, the higher elevations. Same thing, kind of sheer in there, and these are directly moving north. So maybe supercellular in that case. Good 3 cape. If they work on a vorticity boundary, that'll definitely be useful for them. Possible semblance of capping, but there's enough forcing these should get through. And also hail for that in those northern storms as well. You can see a huge plume of cape in that hail growth zone. Might even be most of the cape from this whole CUT. Finally, look at our last photograph here. This is from this other sounding here from Kansas. Again, this is a GFS model as well. More capping in place with this one, but you can see the shears very similar as well. Very good rotation. Not as much jetting off the precipitation here, so curious how that'll work out. I think the GFS isn't really the best option for this. I'll definitely have another video coming out when we get the RAT model as well. But yeah, you can see that's kind of our environment we're looking at. The 30% is definitely warranted for this scenario, and it's been in place for a while now. So I definitely trust the SPC. The Chicago State, sorry, I believe this Colorado State University has a machine learning program as well, and it also has a very well defined area of severe weather right in this vicinity. It definitely likes the Kansas option a little more than the SPC seems to right now. But yeah, definitely big old area of possible severe weather for the United States according to this product here. So interesting to look at that as well. Last thing I'll look at for this is going to be our day 5. So as the storm system on, this is low pressure. Again, very strong low pressure. This is 990 millibars almost. You see on Tuesday, our main area of interest, from what I can understand as well from the everything going on here, is going to be this corridor, kind of around the Missouri, Iowa, and Illinois tri-point, but honestly, everything surrounding that as well. I believe the Colorado State also agrees with me here. They even show a stronger severe weather event for this vicinity as well. So, and definitely possibilities with that. I'll take a few soundings here as well. The GFS isn't as trustworthy for soundings really, but we'll take a few just to kind of understand. Take one right in that center of region we want to see. Maybe one right here in Missouri, and I'll take one here in Eastern Illinois. That's what we're looking at in that regard. Here's our one right in the center. Yeah, not super impressive cape. If you look at the cape values for this system, not really high up there, right? MU cape, most unstable cape, isn't barely even hits 1500, 1600 cape, so nothing too high for that. The wind profiles are also interesting though, because we are seeing definitely a lot of shear for this entire region. Even here for the, I believe this is the Missouri sounding here. Yeah, the Missouri sounding, you can definitely see more supercellular rotation at lower levels and then jetting off the wind. So, not what you want to see there. Also, good capping, just completely gone. 3 cape as well. So, one strong thing with the system is going to be all of that capping possible. And then our Illinois system here with that kind of supercellular look, just not really a very good photograph and CUT together. A little bit of semblance of rotation, but if you don't have if you don't have any cape, 112 is nothing. Can't use that at all. Then you don't really have a good photograph in CUT. So this second day, I'm also very interested in, just to be closer to me. We'll see how that plays out as well. Going further than that is a little bit uncertain. SPC also doesn't have anything out for that, so you know it can change. The GFS likes the option of, I believe, a secondary surface load kind of forming behind this. See that right there if it'll load. The second surface load, I believe, is zipping up the front here. So maybe another day of severe weather there, but you can see with the system, just a huge warm sector continually. Here's our low, and just a huge area of warm, moist air that is primed for storms. So this will be quite a prolific outbreak. I am interested to look at how it'll get as we get closer to the event. And again, I'll definitely have another update out when we get closer, just because this is a very prolific event, and I want to make sure I make videos on this. This is probably might be one of our most severe days we've had all year, and might be the most severe day we have all year. We don't know what's gonna happen in the future. So, yeah, well, interested to see how this will look. With that, thank you for watching. I will see you next time.